Hello everyone and welcome back to my channel. So in today's video we are going to build something really exciting in a Cisco Meraki server using Python. We are basically going to go through the code that we have already built, right? And we will dive into that code. And before going into that, we need to understand what actually MCP is. I believe I've already taken a couple of sessions on the MCP, and we have also tried to build some of the agents where we have tried to approach vendors like Cisco Meraki to functionalities. So basically the MCP stands for the Model Context Protocol. If you would see my video, we created an agent which was able to uh, you know create a particular network, then provision a template, and then bind a particular template to the network, which was created by us, but that was agent. Now what we have done is that in this session we have enhanced that particular code, right? P basically stands for Model Context Protocol. You can think of it as a common language that allows AI assistant to communicate with external applications and services. Without MCP, an AI model can answer questions, but it cannot directly interact with your infrastructure. So, for example, imagine asking an AI to create a branch of its network. So normally the AI has no way to log into the Cisco Meraki and perform that task, right? So with MCP, the AI doesn't call the Cisco API directly. Instead, it calls the MCP tool, and our MCP server performs the actual API request, right? So if I take, I have created something. Maybe I'd like to showcase it to you. Just give me a moment. So yeah, so basically we have an interactive client from where we will use the MCP protocol, which will basically leverage the Cisco Meraki MCP server, the Python wrapper, and the REST API request will go to the Cisco Meraki dashboard, and we will be able to uh, you know um, able to leverage this MCP server to get the desired tasks or the functionality executed or the workflows getting executed on the Cisco Meraki dashboard, right? So let's go into the code and deep dive into it, like what we have built, right? So let's first start with this configuration called as the config API, right? So basically that loads the configuration and validates the uh, environment variables. So when I talk about that, right, so instead of doing hard coding on our Cisco Meraki API key, so we have read it securely from the environment variables, right? So you can see that I have used the python.env library, right? And basically we have hidden our Meraki API key, right? And after that, and basically this is done to keep the sensitive credentials out of our source code and makes the our project much easier to share it with GitHub. This way every API call automatically includes the authentication, right? You can see we have taken up the MCP host in the port. So basically my laptop is connecting like an MCP host, and this will be the port number, right? uh, Moving on to the Meraki.py file. So basically this file contains our Meraki wrapper class. So you can think of it as uh, 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 Python interface to the Cisco Meraki dashboard, right? We have written the generic request calls to get the organization, get the list the networks, create networks, uh, delete the networks, get network information, list the templates, get template ID, create the templates. So all these kind of functions, get the template information, all these functions have been written, bind the template to a network. All these functions have been written inside the Meraki.py. So instead of writing the HTTP request everywhere in the project, we have centralized everything into a single class, and the first thing this class does is to connect to the dashboard and retrieve the org ID. After that, we create a generic request function. Every REST API, whether it is get, post, delete, or port, passes through the single line function. That means we only write authentication, error handling, and logging once. From there, we built reusable methods. For example, create network, delete network, list network, get network information, create template, list template, and all those sorts of the functions. So each of these methods simply calls the generic request functions with appropriate endpoint, and this keeps the code clean and easier to maintain, right? uh, Now let's move to the heart of the project, which is basically the app.py, right? So this is our MCP server, right? So if you can see at the top, we have used the FastMCP, and we have used the Meraki module also over here, right? So here we basically create a FastMCP application, right? At the bottom you can see that from here basically the MCP server gets started, where we just perform mcp.run, and our transport type is streamable HTTP. If you would look into my previous video, I would have talked about it, right? uh, so coming back to the the main point, which is the app.py. So we expose each Meraki operation as an MCP tool. For example, when we create the MCP clients, uh, sorry, when an MCP client calls the tool name create network, our server simply calls the corresponding Python method inside the Meraki class. And the same happens for listing the networks, creating the templates, deleting networks, and every other operation, right? So this means our REST APIs are now available as standardized MCP tools. The really nice thing about this design is that the AI assistants don't need to understand Cisco APIs anymore, right? uh, so now let's look at the client.py, right? uh, so let me go over there. Yes, so this is basically the uh, uh, connection to the MCP server. So basically uh, we use the streamable HTTP, so the client will be able to connect the MCP server, and once the client gets connected to the MCP, it will initialize an MCP session, and it will discover all the available tools. So after that, we can type simple prompts in plain and simple English, uh, uh, such as show all the networks, or create a network name template called as daily office, right? You would be able to see all the commands which I have listed over here, right? As a part of the comments, right? You can also see it inside my code as well, right? So I have used regular expressions uh, to search for the pattern, what you have typed over here. You can see what values are getting created over here, which function is getting returned, right? And how the functions are getting mapped to uh, particular prompt, right? So the MCP server, the client will convert these prompts into the MCP tool calls, and the MCP server will receive those requests. The server will then call the Meraki wrapper, and the wrapper invokes the Cisco Meraki Dashboard APIs, right? So finally, the response flow back through the same chain to the client, and this demonstrates the complete life cycle of an MCP request. Uh, the, so one thing to understand is that our client uses simple rule-based parsing. In a production environment, you would typically place an AI model such as GPT between the user and the MCP server. The AI would understand the natural language and determine the appropriate tool, prepare the required arguments, and it will then invoke the MCP server automatically, right? So that is exactly how modern AI assistants interact with external systems. So our architecture would become, user, GPT, from GPT to MCP server, and then from MCP server to the Cisco Meraki, right? So this architecture basically separates the reasoning from the execution. The AI decides, what to do. The MCP server safely performs the action, and the external application executes the request. So this separation makes enterprise automation much more reliable and secure, right? The best part is that adding the new functionality is extremely easy. if tomorrow we want to manage VLANs, firewalls, rules, switchboards, wireless, SSIDs, VPNs, etc., we create a simple Python function. We add this Python function, or we add the REST APIs into the the Meraki.py section. We leverage it through the client.py, which will probe the app.py, or basically uh, the MCP server. How we basically have to call that particular function, and no changes will be required to the client architecture, right? So the architecture would remain the same. I hope this project would have helped you to understand not only how to build the MCP server, but also how the AI agents can securely interact with the enterprise networking platforms like Cisco Meraki, right? Let's get into the uh, execution. Is basically our MCP server. So let's launch the MCP server. Let's wait for it. And just to inform you, I am currently using the Cisco Meraki, which is the currently, if you see over here, there is no network created, right? We have a couple of commands which we can use, right? I have already put them over here, right? So we are going to take one each of them, and then we will try to hit them, and let's see what happens, right? I've not tried all of them, but we'll try it in front of you. So we are currently waiting for the app.py to launch. It's taking a bit of time, as my laptop is a bit slow on the processing part. So let's wait. Okay, let me close out the VS Code, as we have already explained most of the parts. So let me try to do that, and let's see if it works properly. I'm closing my VS Code right now because okay, let's see. Okay, let me try again. See if it doesn't work. Then do that again. Okay, now the MCP server has started successfully. Right, you can see the MCP server is started, and the uh, application is currently running on this particular IP address, which is basically the loopback IP address, and this is the port number, right, where the MCP server is running. Now let us power on the client.py file, right? So you can see that I am on the particular Meraki MCP folder where we have created and put up all the files, right? So the structure would look something like this, right? So this is the complete structure. You can see we have a readme file, we have a Meraki file which you are talking about, where we have kept up the config, all the files. The config file, where we are loading the environment from. The client file, of course, where we are probing the MCP server, right? We are talking it in an interactive format, and we are trying to create everything from here by giving the prompts. And then last but not the least, the most important part is the app.py, which is basically your MCP server, where we are uh, you know uh, which is the basically the brain or the heart of this particular project, which helps you to take the request towards the Cisco Meraki dashboard, and then get all the tasks completed, right? So let's go to the prompt and try to power on the client.py. Let's wait. Right, so as soon as I powered on the client.py, you can see that there was a post request that went to the MCP server, right? It was trying to reach, right? So that means that the MCP server has been the MCP client has been able to connect to the server successfully, right? So let's see what happens. Let's first have a look at the Cisco Meraki dashboard, right? So currently you can see that there is no network created, right? Let me go ahead and refresh this. Okay, let's wait for refresh to happen. As my laptop is a bit trying to get the uh, things refreshed. Okay, so you can see that there is currently no network created. Now let me copy a prompt from here, right? So I will create basically a network, and I will call that network daily office, right? So let me take this and let me paste it over there, right? Okay, so I've done that, and I'll paste it now. So you can see that the client is calling the function that we have written at the back end, right? The MCP server is leveraging it, and it is creating a particular agent, right? So now if I refresh this, I can see that now the daily office is created. Also, if I go to the command prompts, right, you can see that what post request was being sent, right? So the network was getting created and there was the reply. The status code you can see is a 201, right? So the network was created successfully, and you can see the prompt coming on the MPT. Now let us create one more server. Let me paste it over here, and instead of daily office, let me call it Divakar 1. Okay, let's create a more networks, right? So you can see that simultaneously that the networks are getting created successfully, right? So that's done. Now we have two networks over here. Let me quickly refresh it. Okay, so let me hit refresh. So you can see now that the network has been created successfully. Now we have two networks. So if I go over here and one of the prompts, let me copy this command and I will put list all networks, right? So list all networks, and let's see what it does. Okay, so yeah, we are able to see both the networks. So I'll have to scroll up. So this is one and this is two. You can see the LIDs for both the networks, right? And on the MCP server you can again see that there was a command that was issued over here, right? And we got 200. I think that was for the previous one maybe, but yes. Okay, so we have given a blank command, so it was not able to understand it. Let us try something more. uh, let's remove the network. Okay, okay, let's remove the network. So I will say remove network Divakar 1 instead of daily office. Let's remove the network. uh, Network name was Divakar 1. I think that is the network name, right? Yes. Okay, so let's remove the network. Okay, let's see what's happening over here. So this is the way, once the network gets deleted, right? So you would be able to see the kind of API request that is going to the MCP server, and you would be able to make out that how the what process is going on, right? So you will get a gist about that, right? Now just excuse me. Okay, so that's okay. And now let's create a template. So I'll go to the my readme.txt file, uh, and we will try to create a template. Okay, so let's create a template named branch template, right? We'll do that. I'll create a template named branch template. You can see immediately as we fired up the command, the config template was created successfully, right? So you need to understand that MCP servers are something that you can create even on a Windows server or a Linux server, that's all right. And through a gateway or some particular process, the MCP servers are not respond to you directly. Either you need to integrate them with some of the uh, I would say the AI clients or the AI hosts, which is basically could be Cloud desktop, where you will have to create an agent, and then basically that agent could leverage the MCP protocol. So it will become basically your MCP client, the AI agent which you have hosted on a AI host or agentic platform, and then it is going to interact with the MCP server through the uh, obviously the MCP protocol, right? So there is a transport layer that helps you to carry your information, right? And what variables needs to be changed is basically your the data layer, right? Or what values you want to get fetched. So now we have created the template. Now let's go ahead and bind the template. So bind the template, branch template to the Delhi office, right? That is what we are going to do. Before we type that, let's quickly go and have a look if the template was created, right? So uh, pardon me, I just forgot that completely, right? So now you can see that the branch template has been created successfully, but you can see that uh, the bound networks, there is no binded network, right? So let's go ahead and bind the branch template with the network that we created, right? So that name is Delhi office, right? So that is correct. We'll have to bind the branch template with the network. uh, just give me a moment. Go there. Yeah, so this is the name of the network, Delhi office, right? So I'll have to bind it. Now let's press it. So you can see that it's success. The network Delhi office has been bounded successfully to branch template, right? And now if I refresh it over here, you can see the count getting increased from 0 to 1. That means one network has been bound, and as you are aware, we have only one network which has been bounded, is the Delhi office, which has been successfully mapped with the branch template, right? You can even open it over here and you can see the name of the network binded with the template, right? So that's quick and that's quite easy, right? We can also search the number of templates over here. So I just have to copy paste this commands, right? So I'll just say list templates. If you list template, you will get the template that we have created, right? So these are two templates. One is the branch template and one is the HQ template. You can see the names also over here and correspondingly their LIDs, right? So that's about it from my side, right? And I think this was uh, quite I would say elaborating a video. I think we have done quite the coding part as well, but for this particular video I kept the coding part a bit to a lower level. If you think that I need to put the code in front of you or start coding and then develop a complete MCP server, I am all up for that. We can do that, but I think most of that part, uh, at least for the MCP server, and was covered separately. And also the video where we created the agent for the Cisco Meraki, where we tried to create the functions for the provisioning and all, were also covered as part of one of the other videos, right? But still, if you want, I will put up the code into my GitHub, and I will paste it as a part of the link where you guys can go ahead and you can have a look at the MCP server, and also if you want you can leverage it as per your convenience, right? So that's all from my side. uh, Hope you would have enjoyed my video, and I would see you in the next video. Thank you so much.